Now let's take a closer look. The June 2024 Top 500 Supercomputer list was released at ISC, and there's a lot to unpack there. The Top 500 Supercomputers list includes some significant trends in the supercomputing landscape. NVIDIA takes 7 spots with Grace-based systems, including 3 of the top 20. The balance between Intel and AMD remains pretty much static, but there's a shift toward co-packaged CPUs and accelerators, which is interesting because Intel just announced that they're going to sunset Ponte Vecchio, their entry in the space, and skip the next generation of their integrated co-packaged CPU and GPU architecture. Interestingly, HPE was a big winner here. They are leading in developing and deploying new supercomputer systems, and they enable 8 of the 10 Grace and MI300A entrants on the list. We also see ARM well represented on the list with 8 new servers, which signifies another shift in the space. One of the things that I always look for in the supercomputer list is the trickle-down effects that happen. Since supercomputing is one of the key platforms that proves out new technologies, like integrated CPU and GPU, new connectivity approaches, new CPU architectures, new accelerators, and that sort of thing. But of course, supercomputing is not enterprise computing, it's not cloud computing, and many of the technologies that appear there and are adopted there never really do make their way down into the enterprise. But let's take a closer look at the impact of some of these announcements on enterprise and cloud systems. Mitch, what's your thoughts on the top 500 supercomputer list?
Well, it's interesting. Hardware is cool again, Stephen. And supercomputing has always been cool, of course, now because of AI and NVIDIA and of course, ARM playing a bigger role in our worlds. I think it's really changing the landscape of supercomputing. The static or relatively static competition between AMD and Intel is not surprising, but Intel's also making a massive investment in becoming a foundry for other companies to manufacture their chips as well as Intel chips for them. We'll see what impact that has here. Of course, NVIDIA taking 7 spots is not entirely surprising, but it's good to see with the popularity of their Grace Hopper-based CPUs. If don't know who Grace Hopper is, please Google her. You'll learn that a lot of what we do today is based on her early contributions to the industry. Also, I think ARM is particularly notable, and I spend time around open source projects, and they've made a big investment in making sure that open source projects, for example, are deployable and supportable on ARM systems, primarily for edge computing, but also other applications. So they're making a big shift, not in just using ARM in the data center, but making sure that software can be delivered and run on ARM processors. So it's good to see this. Of course, where's quantum on the horizon? How soon that will be here? It's making progress, but we have a ways to go. So interesting innovations occurring across the board here.
Yeah, let's dive into some of these specifics here. One of the things that really caught my eye, as well as the eye of the analysts here at Futurum, was the incredible impact that co-packaged GPU and CPU systems are having on this list. So we've got, obviously, I mentioned that NVIDIA has a bunch of these Grace Hopper CPU, GPU combos on the list. Those of you who have watched the rundown know this, but essentially Grace and Hopper are NVIDIA's, now previous generation, but still pretty awesome CPU and GPU. And they co-package those with on a single device with high bandwidth memory as a way to deliver maximum performance. And now we've got a bunch of Grace Hopper based systems out there in the supercomputing space. If we believe, and I certainly do, what Lisa Su has said about co-package, it is really a tremendous benefit in terms of power, not just performance, because we spend a lot of time and a lot of energy moving data around from system memory to GPU and so on in a more conventional system. And co-packaging those delivers incredible performance. I think those of us who are using Apple's M family of CPUs can see that as well, because they've taken a similar approach of putting memory, CPU, GPU, TPU, accelerators, all that on the same package. But it's interesting that while we have these Grace Hopper systems and MI300A systems from AMD coming into, up to speed, we also have Intel's co-packaged Ponte Vecchio systems, including the number 2 on the list, number 2 with a bullet, and maybe even number 1 when you run the right performance test on it, coming from Intel. And yet, Intel has kind of backed off from their promises of co-packaging all sorts of things in the next generation of products. In fact, it looks like Intel's next generation is going to be pretty much a conventional architecture where you have a GPU add-in card communicating over PCI Express with CPUs. That's kind of a surprise. I don't know what is going on quite with this, except to say that Intel maybe felt that there just wasn't enough market time for another generation of products to come to market, develop a market, be delivered, and so on. And they would rather hold off until they have a really compelling competitor for the next generation products from NVIDIA and AMD, which have now been announced. NVIDIA's Blackwell looks just incredible. I can't wait to see the GB200 and what that thing will be able to do. I imagine that there will be some of those systems on the next supercomputing list. But despite the fact that they're still holding strong, I think that Intel is going to kind of miss out on a wave of supercomputing upgrades over the next year. What do you make of all of this sort of Intel, NVIDIA, AMD battle?
It is a head scratcher. While Intel would kind of go back to a traditional path around separate GPUs and CPUs, because of the system on a chip certainly has taken kind of the industry by storm. A lot of people doing that, of course. This is pure speculation on my part, but the thing I wonder about is, are there added complexities of delivering a product that's a system on a chip that by not doing so, Intel might be able to innovate faster in their CPU and GPU product lines, taking that kind of traditional dual path? There may be other reasons as well. We'll have to see, but clearly Intel's been behind in the AI space for those reasons. So maybe they need to do catching up on that before they kind of go back to a system on a chip approach. We'll see where that goes, but that's how I can put the logic together of why that might make sense.
Yeah, indeed. This actually makes me think of Pat Gelsinger wielding the mighty CEO machete on product plans. Maybe he looked at the roadmap, he looked at the timing, he looked at the development space, and he said, you know what? There's just not market space for these products, and had the foresight and ability to go in there and say, no, these are done. These are done. These are done. We're going to skip these. We're going to move right on to next generation. Seems like that's what Intel is doing in a lot of the market. They're willing to give up short-term market share and give up short-term wins in favor of bringing really competitive next generation products to market. I also think that there's a trend at Intel to focus on the truly competitive space instead of basically trying to take what volume they can with what products they've got coming along in the pipeline, and instead say, no, we want leading products on leading process nodes that have really leading margins as well. And frankly, these products are not going to cut it, because frankly, that's kind of what we've seen here. But of course, that's a short-term risk for Intel, because they probably are going to be losing market share. The fact that Intel and AMD have roughly the same market share in the supercomputing list also is interesting, because of course it shows that AMD is actually doing incredibly well in the HPC space, much better than it's doing in cloud or enterprise or certainly mobile devices. And yet that hasn't yet affected Intel as much as you might think, since people still are buying Intel in all of those spaces, including in HPC. Now, the ARM question is another really interesting one as well. We do see ARM-based supercomputing. We've seen some really cool announcements. There was an AI large language model developed in Japan recently on an ARM supercomputer that is on the list here. That was pretty neat to see. Do you think that alternative instruction sets like ARM and maybe even RISC-V are going to have an impact on HPC? And do you think that that's a signal of some kind of change?
I think you already said it. It has happened. Just the M1 chip series or M chip series from Apple, which interesting. There was a disturbance in the force recently with the M series. Excuse me, with the M series around the announcement of the iPads. The higher end iPad is actually skipping the M3, going for the M4. And reportedly, there were some yield problems with the M3 chip because they're using a kind of one generation behind manufacturing process. So they're de-emphasizing M3 and moving to M4. Maybe we'll see that happen more quickly than traditional. But the M series is an ARM-based processor. Kind of tied to some of our previous story. If you've been running VMware Fusion on a Mac, you know that suddenly that didn't work because it's built for Intel processors. So you had to find an alternative. And I think Apple's another example of showing that ARM is very competitive. And I think it's also enabling to go faster to market. And of course, not pay homage or licensing royalties to Intel in the process. So I expect that to continue to grow, just like we're seeing with NVIDIA.
Yeah, absolutely. Full disclosure, I actually have a M4 iPad Pro sitting on my porch at home as we are recording this, and I'm eager to open it up and give it a shot. It is an impressive device, and as you mentioned, the nuance there I think is important. Apple moved forward aggressively into 3-nanometer process nodes, but TSMC's second generation or so-called second generation 3-nanometer process node is really where the future is. I suspect that the M3 generation is going to be a very short one indeed, and Apple's going to move to M4 with pretty much everything else. Kind of tying in with all of these discussions, though, I think that we're going to see more and more rollout of processors that are complete systems, whether in mobile devices, in corporate devices, in the data center, in the cloud, in HPC. We're going to see more and more emphasis on co-packaged devices that include memory, CPU, GPU, accelerator, et cetera, all on the same package. I think we are going to see an aggressive move into devices like Intel's Ponte Vecchio that combine multiple different chips, multiple different process nodes, multiple different sources on the same device. And I think that that's really the future of computing overall, whether it's on an iPad or on the HPC list. And I don't think Intel is going to miss out on that trend. In fact, I think that Intel is wisely skipping a couple of steps in order to stay ahead there. So those are the kind of things that I'm reading out of this top 500 supercomputer list. If you have some feedback on this, we would love to hear from you as well. What did we get right? What did we get wrong? Drop us a message. We'd love to hear from you.